Thanks for choosing products from Synovision. Today I will introduce the operation of the Cardiac Function Analysis plugin. Based on the retrospective cardiac CT data, this plugin will segment ventricle and myocardium automatically, provide ventricular function parameters, bullseye map and virtual video showing the heartbeat. It will assist the user to evaluate the ventricle function and assess the myocardium situation. Now, please allow me to introduce and demonstrate the operation of cardiac function analysis. In the patient list, select the patient for cardiac function analysis. Select at least 2 phases in the sequence listed below. Click the right mouse button to open the drop-down menu. In the Add Process menu, select Cardiac Function ANA to enter the CFA interface. You can also enter the interface by selecting CFA in the Function Switch panel located in the lower right corner. When the image is done loading to CFA interface, the heart, left ventricle and left ventricular myocardium will be extracted and analyzed automatically. This process will take a few seconds. The loaded cardiac phases are displayed in the upper left corner of the screen. The 3 images correspond to the 3 standard planes of the heart: the short axis plane, the horizontal long axis plane. In this view we see the 4 chambers of the heart. The vertical long axis view, or otherwise known as 2-chamber view. The red tissue in the images represents the ventricle, and the blue represents the myocardium. In the middle, it shows the ventricular function parameter table, including ejection fraction and systolic volume and diastolic volume, stroke volume, stroke index, myocardial volume, myocardial index, heart rate, height, weight, body surface area BSA, cardiac output per minute, cardiac index, and myocardial mass, follows by the ventricular volume curve and VIA image. The right side displays the bullseye maps. From top to bottom represents the wall thickness, wall motion, and wall thickening rate. Double-click the pseudo-colors ruler on the left side of the bullseye map to adjust the color scheme. The color on the displayed ruler corresponds to the parameters on the map from low to high, according to the color display on each bullseye map. It is helpful to assess the myocardium situation comprehensively. On the 2D viewport, in the lower left corner of the 2D image, right-click on the text to switch between the 2D MIP, AIP, and MiniP display modes. In the lower right corner, left-click at the blue text window width and window level to manually adjust the window width and level. In the lower left corner of the VIA image, right-click on the text VIA to switch to other display modes. Double-click the text protocol in the VIA image, and the opacity protocol window will pop up. Then we can adjust the opacity protocol. In the upper right corner, right-click the text left ventricle to switch between all, cardiac and left ventricle. The right side is function operation panel. The upper part of the panel is the patient information. Below are general toolbars. What we need to know here is the positioning line, which determines whether to display the positioning line in the cardiac axis images or not. Contour line determines to display the contour in the short axis images in 3x image layout. Organization marker determines to highlight the marked tissues. Restore to default location is used to reset the default cardiac base and apex for the currently selected phase. There are 4 viewport layouts. 3x3 layout shows 3 cardiac axis images, 1 VIA image, cardiac function parameter table, cardiac volume curve, and 3 bullseye diagrams. 2x2 layout displays short axis image, 2-chamber image, 3-chamber image, and 4-chamber image. This heart image in 3 dimensions demonstrated the conventional imaging planes. 2+2 layout displays 3 ventricular axis images and 1 via image. 3x(n) layout displays continuous short axis images, which are used to edit the contour. Cut tools only applicable in the VR image. Modify ES-ED information. ES stands for end systole, and ED means end diastole, which is used to modify ES and ED phase manually. After clicking OK, the results will be updated according to the modified ES and ED automatically. Modify patient information is used to modify the heart rate, height and weight of the patient. After clicking OK, the result in table will be updated accordingly. Positioning line analysis according to the modified new base and apex. Segment the ventricles and calculate again. Meanwhile, it updates the image and table. Click the Edit Contour, the layout will be switched to 3x(n) and displays the contour of the LV and myocardium, both are editable. Dragging the control points to edit the contour. Click OK to save the edited result, cancel to quit the edited result. When changing the layout, a prompt message asks if the left ventricular should be extracted according to the new change. Press Yes to update all final results. Press the Modify Patient Information and then Yes to update the table too. 4D Play panel can perform dynamic heart playback, allowing simultaneous playback of all windows or single window. Adjust the playback speed and direction here. Here we take the 4D playback of the aortic valve as an example. Adjust the angle of the long axis, so that the long axis is parallel to the direction of the aorta. Move the short axis plane to the position of the aortic valve. We can change to MIP view. If you need to save as movies, click Tool in the lower right corner. Select Full Screen to save a movie with full screen. If window is selected, then save the movie only with the selected viewport. After clicking the record icon, select a save path in the pop-up window. Then clicking the OK button, the recording is already started. Go to the previous panel to start the playback. Click Pause to pause the recording, or Stop to end the session. Click Play to view the movie. According to the International Standardized Segmentation Model, the segmentation of the bullseye map on the left ventricular planes is standardized by the American Heart Association, and the left ventricle is divided into 17 segments. That is, in the long axis, the left ventricle is divided into equal thirds, which are the basal, mid and apical thirds. The tip of the apex forms a separate final segment. When these thirds are viewed in the short axis, they form rings that are numbered counterclockwise, which can be divided into equal sectors. The basal third has 6 sectors. From segment 1 to 6 they are basal anterior, basal anteroseptal, basal inferoseptal, basal inferior, basal inferolateral, and basal anterolateral. The mid-third has 6 sectors too. From segment 7 to 12 they are mid-anterior, mid-anteroseptal, mid-inferoseptal, mid-inferior, mid-inferolateral, and mid-anterolateral. The apical third has 4 sectors. From segment 13 to 16 they are apical anterior, apical septal, apical inferior, and apical lateral. Finally, the tip of the ventricular apex is one segment of its own, apex segment 17. This is the assignment of the 17 myocardial segments to the territories of the left anterior descending LAD, right coronary artery RCA, and the left circumflex coronary artery LCX. Here is the introduction of cardiac function analysis. Thanks for watching.